7th lesson, whole numbers. Warm-up time. Observe the picture given below. Learning time. In this lesson, we shall learn more about properties of whole numbers. We know that 0, 1, 2, 3 are called whole numbers. We have learned about even and odd numbers in earlier lessons. Do you remember the rules to identify even and odd number? Even numbers. The number that can be divided exactly by 2. The last digit will be 0, 2, 4, 6 or 8. For example, minus 24, 0, 6 and 38 are all even numbers. Odd numbers. If it is not an even number, it is called an odd number. The last digit will be 1, 3, 5, 7 or 9. For example, minus 3, 1, 7 and 35 are all odd numbers. Adding and subtracting. When we add or subtract odd or even numbers, the results are always even plus even equals to even, 2 plus 4 equals to 6. Even plus odd equals to odd, that is 6 plus 3 equals to 9. Odd plus even equals to odd, that is 5 plus 12 equals to 17. Odd plus odd equals to even, that is 3 plus 5 equals to 8. The same thing happens when we subtract instead of adding. Multiplying. When we multiply odd or even numbers, the results are always even into even equals to even, 4 into 8 equals to 38. Even into odd equals to even, 4 into 7 equals to 28. Odd into even equals to even, 5 into 8 equals to 48. Odd into odd equals to odd, that is 5 into 7 equals to 35. Activity 1. Circle the even numbers from the following numbers. One number is circled for you. Second, write all the even numbers between 45 and 65. Write all the odd numbers between 33 and 61. Write all the 3 even numbers after 265. Write the 3 odd numbers after 360. Write all the even numbers between 5400 and 5425. Test of divisibility. A quick way to check if a number is divisible by another number is called test of divisibility. Test of divisibility for numbers 2, 5 and 10. For number 2, the condition is a number is divisible by 2 if the numbers have 0, 2, 4, 6 or 8 in ones place. For example, 128, 146, 432, 636. For number 5, condition is a number is divisible by 5 if the digit in the ones place is either 0 or 5. Example, 250, 1200, 355, 4500. For number 10, the condition is a number is divisible by 10 if the digit in the ones place is 0. Example, 300, 240, 4560, 35600. Test of divisibility for numbers 3, 4, 6, 9. For number 3, the condition is a number is divisible by 3 if the sum of the digits is divisible by 3. For example, 432. Sum of the digits 4 plus 3 plus 2 is 9, which is divisible by 3. Hence 432 is divisible by 3. For number 4, the condition is a number is divisible by 4 if the last two digits are zeros or if the number formed by its last two is divisible by 4. For example, 400, 3800, 4200, 6000, the last two digits are zeros. 4388, 8316, 6552 and 3496. The number formed by the last two digits is divisible by 4. For number 6, the condition is if the number is divisible by 2 as well as by 3. This means that an even number which is divisible by 3 will be divisible by 6. For example, 84, it is an even number, so it is divisible by 2. Sum of the digits 8 plus 4 is 12. 12 is divisible by 3. Hence, 84 is divisible by 6. For number 9, the condition is if the sum of the digits of the number is divisible by 9. For example, 729, sum of the digits 7 plus 2 plus 9 is 18, which is divisible by 9. Hence, 729 is divisible by 9. Activity 2. By using the test of divisibility, answer the following. First, write the numbers which are divisible by 2. Second, which of the following are divisible by 3? Third, which of the following are divisible by 4? Fourth, which of the following are divisible by 5? Fifth, which of the following are divisible by 6? Sixth, which of the following are divisible by 9? Seventh, which of the following are divisible by 2 and 3? Eighth, which of the following are divisible by 3 and 9? Multiplies and factors. Multiplies. From the multiplication table of 5, we know that when we multiply any number by 1, 2, 3, 4, etc., we get the multiplies of that number. So 5, 10, 15, 20 are called multiplies of 5. Similarly, multiplies of 6 are 6 into 1 equals to 6, 6 into 2 equals to 12, 6 into 3 equals to 18, 6 into 4 equals to 24, 6 into 5 equals to 30. Hence 6, 12, 18, 24, 30 are multiplies of 6. Remember, the smallest multiple of a number is the number itself. For example, in multiplies of 6, the smallest multiple of 6 is 6 and that of 5 is 5 and so on. Properties of multiplies. First, every number is a multiply of 1. For example, 1 into 6 equals to 6, 1 into 7 equals to 7, 1 into 10 equals to 10 and 1 into 11 equals to 11. Second, every number is a multiply of itself. For example, 3 into 1 equal to 3, 4 into 1 equals to 4, 5 into 1 equals to 5 and 6 into 1 equals to 6. Third, 0 is a multiple of every number. For example, 2 into 0 equals to 0, 10 into 0 equals to 0, 22 into 0 equals to 0 and 70 into 0 equals to 0. Fourth, every multiple other than 0 of a whole number is greater than or equal to the number. For example, 8 into 1 equals to 8, 8 into 2 equals to 16, 8 into 3 equals to 24 and 8 into 4 equals to 32. So first four multiples of 8 are 8, 16, 24 and 32. Fifth, every multiple of a number is exactly divisible by the number itself. For example, since 7 into 8 equals to 56, that is 56 is a multiple of both 7 and 8. Since 56 divided by 7 equals to 8 and 56 divided by 8 equals to 7. Factors. Since 3 into 6 equal to 18, we say that 3 and 6 are the factors of 18. It means that 18 is divided exactly by both 3 and 6. So 18 divided by 3 equals to 6 and 18 divided by 6 equal to 3. That is, the product divided by one factor gives the other factor. We can find out all the other factors of 18, that is 1 into 18 equals to 18, 2 into 9 equals to 18, 3 into 6 equals to 18. Thus 1, 2, 3, 6, 9 and are 18 factors of 18. Also 1 is a factor of every number. We cannot divide 18 by 4, so 4 is not a factor. We cannot divide 18 by 4, 5, 7, 8, etc. So these are not factors of 18. The last factor is 18. 1 equals to 18, the number itself. Every number other than 0 is a factor of itself. For example, find all the factors of the following given numbers. First, 54. Second, 42. Third, 128. Solution: 54 equals to 1 into 54. 54 equals to 2 into 27. 54 equals to 6 into 9. 54 equals to 3 into 18. 54 equals to 9 into 6. The factors of 54 are 1, 2, 3, 6, 9, 18, 27 and 54. Or, in pairs, the factors of 54 represented as 1 into 54, 6 into 9, 9 into 6, 2 into 27, 3 into 18. Second, 42 equals to 1 into 42, 42 equals to 2 into 21, 42 equals to 3 into 14, 42 equals to 6 into 7. The factors of 42 are 1, 2, 3, 6, 7, 14, 21 and 42. Or, in pairs, the factors of 42 are 1 into 42, 2 into 21, 3 into 14, 6 into 7. Third, 128 equals to 1 into 128, 128 equals to 2 into 64, 128 equals to 4 into 32, 128 equals to 8 into 16. The factors of 128 are 1, 2, 4, 8, 16, 32, 64 and 128. Or, in pairs, the factors of 128 are 1 into 28, 2 into 64, 4 into 32, 8 into 16. Activity 3. Section A. Find all the factors of the following given numbers. Section B. State whether the first number is a factor of the second or not. Section C. Answer the following. First, is 0 a factor of 35? Second, is 8 a factor of 188? Third, is 5 a factor of 1540? Fourth, is 1 a factor of 4121? Section D. Answer the following. First, write the first 4 multiples of 12. Second, write the first 5 multiples of 9. Third, write the first 3 multiples of 14. Fourth, write the fourth multiple of 15. 5. Write the ninth multiple of 30. Sixth, write the least multiple of 160. Prime and composite numbers. Prime numbers, a number that has only two factors, I and itself. For example, 2, 3, 5, 7. Composite numbers, any whole number with more than two factors, that is 18, 24, 35. Let us write all the factors of numbers from 1 to 12. Number, factors. We notice that, first, 1 has only one factor and that is itself. It is called a unique number. Second, the numbers 2, 3, 5, 7, 11 and 13 have only two factors, 1 and the number itself. Such numbers are called prime numbers. Therefore, numbers having only two factors, 1 and number itself, are called prime numbers. Third, numbers having 3 or more than 3 factors are called composite numbers. Remember, 1 is neither a prime nor a composite number. Now look at the prime number 3 and 5. Their difference is 2. Two prime numbers with a difference of 2 are called twin primes. Some important facts about prime and composite numbers. First, all even numbers except 2 are composite numbers. Second, 2 is the only even prime number. Third, every odd number is not a prime number. For example, 9, 15, 21, etc. Fourth, all the multiples of 3 except 3 are composite numbers. Fifth, all the multiples of 5 except 5 are composite numbers. Sixth, all the multiples of 7 except 7 are composite numbers. Finding the prime numbers from 1 to 100. First, 1 is neither prime nor composite, so strike it off. Second, 2 is a prime number, so leave 2 and strike off all the multiples of 2. Third, 3 is a prime number, so leave 3 and strike off all the multiples of 3. Fourth, 5 is a prime number, so leave 5 and strike off all the multiples of 5. Fifth, 7 is a prime number, so leave 7 and strike off all the multiples of 7. Sixth, the remaining numbers are prime numbers. From the above chart, it is clear that there are 25 prime numbers from 1 to 100. Activity 4. First, the smallest prime number is dash. Second, the smallest composite number is dash. Third, write any two prime numbers whose difference is 1 dash. Fourth, write any two prime numbers whose difference is 2 dash. Fifth, write all the prime numbers between 1 and 30 dash. Sixth, write all the composite numbers between 20 and 30 dash. Seventh, the greatest prime number less than 30 is dash. Eighth, the smallest prime number greater than 20 is dash. Maths lab activity. Help the frog to reach the other end of the pond by jumping onto the leaves which are multiples of 3 and 6 with the help of the below picture.